Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths grade 12 standard, chapter number 5, continuity and differentiability. In exercise 5.1, we are going to see the solution for 15 sum. Okay, already in the last video, still 14 sums. I have uploaded the solution, so please do check. Now let's start with the 15th one. So discuss the continuity of the function f, where f is defined by. So here they're asking us to discuss the continuity, and also they have given the f of x here. So here f of x has a three different functions in the three different conditions. So what are those? So first, using the if conditions, let's break the real line. So we can see very well the 0 and 1 value. So 0 and 1. Okay, so now let's see how many cases we are supposed to take. Okay, now as per the function we have to take. Now for this for this interval minus into the 0, do we have a function? Let's see. If x is less than 0, do we have a function? Yes. So then that means this is going to be our case 1. So here less than 0, we have infinite values. So for all the real values, for considering, let's name the c. Now, to check the continuity, we must have the f of c value and left hand limit and right hand limit. All the three things are required. If all three things are matching, then we can say the function is continuous at x equal to c. We can give the conclusion. Okay. So next is at x equal to 0. So breaking point is what? At x equal to 0 will be our case 2. Okay, at x equal to 0, we have to check the continuity f of 0, left hand limit of 0 and right hand limit of 0. All the three things are required. Now, in this particular interval. So, what is this interval? Interval is from 0 to 1. So, any value lies between 0 to 1. Again, infinite values we have no. So, we have to name as a c. Okay, we can have it as a common number, that is c. We can have it. Then we can check the continuity for this. Then at x, this is going to be like a case 3. Then if for the case 4, if x is exactly 1. Okay, if x is exactly 1, whether function is continuous or not, discontinuing or not, like that we are going to check it. Next, if x is greater than 1, so in this particular interval, we have to finally check. So that means throughout the real line throughout the real line is our domain. So we have to check for the all the real values, depends on the given conditions. Okay, that means to check the continuity, basically we need to take the 5 cases for this 15 sum. Okay, now one by one let's do it. So first case 1. So in case 1, if x is less than 0. Okay, if x is less than 0, we have infinite values, right? So we are going to have a common name. Let c be any real value. Any real value. At the same time, c should be less than 0. Okay, so now to check the continuity, we need three things: f of c, left hand limit, and right hand limit. So first, let's find out f of c. So if x is exactly c, no, c is basically less than 0. Then less than 0, we have to choose the 2x. So that means 2c. Now here basically c lies in this interval. Okay, minus into 0. Here it will lies. Now any value which lies close to c in the left hand side as well as the right side, both are less than 0. So less than 0 means we have to choose the first function only. Okay, for both left hand limit and for right hand limit, in place of f of x we are going to replace 2x. So instead of finding separately left hand limit, right hand limit, we can combine and we can do it together. So limit x is approaching to c, f of x. So suitable f of x is what? 2x, first function. So limit x is approaching to c, 2x. Now applying the limit, that is 2c. Now f of c. So from these two conditions, what we can say, f of c equal to limit x is approaching to c, f of x. So f of x is continuous if x is less than 0. Okay, now in case 2, we are going to check for if x is exactly 0, perfect 0, how our function is going to be. Okay, now case 2, if x is exactly 0. So to check the continuity is, as I told you before, that f of 0, left hand limit of 0 and right hand limit of 0, we have to find out. Okay, so first f of 0, let's find out. If x is exactly 0, suitable function from the given second function. So 0 less than or equal to. Okay, so second function we have to choose. So f of x equal to 0. So if input is 0 also, same 0 only, second function. Okay, now left hand limit, right hand limit, let's see. The closed values of 0, no, anyway this side are less than 0, that means we have to use the first function. And closed values of the 0 in the right hand side are greater than 0, that means we have to choose the second function. So since different functions we have for the left hand limit and right hand limit, separately only we have to do, we should not combine both together. Okay, so left hand limit separately, right hand limit separately, we can find out. So left hand limit x is approaching to 0 from the left hand side, f of x. So left hand side all closed values are less than 0. So suitable function, if x is less than 0, that is 2x. So replacing f of x as a 2x. Now applying the limit, in place of x, if you replace a 0, 2 times of 0, which is 0. So left hand limit is 0. Next one, right hand limit x is approaching to 0, f of x. Right hand side closed values of 0 are greater than 0. So we have to, in place of f of x, we have to choose the second function, which is 0. So replacing f of x as a 0. So since it's a constant, even after applying the limit, it's going to be 0. Now from these three conditions, what we can say, f of 0, left hand limit and right hand limit, everything is same. So we can say that f of x is continuous at x equal to 0. Yes, at x equal to 0. Okay, so two cases over. Next we can third case. What is the third case? If any value lies between 0 to 1 is the third case. Case 3, if x is lies between 0 to 1. So 0 less than x less than 1. So between 0 to 1, in this particular interval, we have infinite value. So let's have a common name. Let C be the any real value. Let C be any real value. At the same time, C should lie between 0 to 1. Okay, so to check the continuity, f of C, left hand limit, right hand limit, three things are required. So first, f of C. Okay, so where do our C has 0 to 1? So suitable function, let's take, suitable function is 0 only. Okay, so if f of x is 0, so it's a basically constant function, whatever input you give, the result is going to be same only, so 0. Okay, next one, left hand limit, right hand limit, and if you notice, we have 0 to 1. So between these only, between 0 to 1 only, we are checking the continuity. So f of C just now we have done. Now for the left hand limit and right hand limit, the closed values of C, which is approximately C only. Such type of values only we will be considering while finding the limit. Now closed values of the C from both the sides, left side, right side, are lies between 0 to 1. So if it lies between 0 to 1, we have only one function. So in place of, while finding the left hand limit, in place of f of x, as well as for the right hand limit to f of x, we are going to use the same function. So instead of finding it separately, we can combinedly do it. So limit x is approaching to C f of x. So suitable f of x is what? 0. Now applying the limit, result is 0. Now from these two conditions, what we can say, f of C and limit x is approaching to C, f of x, both are same. So from this we can say f of x is continuous 0 less than x less than 1. Okay, so case 3 is done. Now case 4. So case 4, if x is exactly 1. Okay, we need to check for if x takes the value exact 1. That is the case 4. If x equal to 1. Okay, then first f of 1. If x takes the 1, the suitable function now. So from the given we can see x less than or equal to 1. So here there is no equal sign, here equal sign we have. So that means f of x equal to 0. So whatever input we give, it's going to be 0 only. So any value from 0 to 1, if you replace, the result is 0. So that means even if take the 1 also, it's going to be like a 0. So f of 1 is 0. Next, to check the continuity, we also need left hand limit, right hand limit. Now let's see whether we can do it separately, left hand limit, right hand limit, or we can combine. Let's see based on the function. Okay, if the function is same, left hand limit, right hand limit, we can do it together. In case if it different, no other option, we have to do separately only. So now left hand side closed values of 1 are less than 1. So less than 1 means we have to choose the second function. Right side closed values of 1 are greater than 1, so we have to choose the third function. So two completely different functions, no? So separately only we have to work out. Now left hand limit x is approaching to 1, left hand side indication is minus sign, so f of x. So suitable function is 0, replacing this as a 0. Now applying the limit, so it's going to be 0 only. Now right hand limit x is approaching to 1 from the right side, f of x. So suitable function is what? Right side closed values of 1 are greater than 1 na? So that means suitable function is 4x. So replacing f of x as a 4x. Now applying the limit, 4 times of 1, which is 4. Now we can see there is a mismatch. So here left hand limit, right hand limit not same. Okay, they both are not same. So we can conclude that for this particular case we can conclude at x equal to 1 function discontinuous. F of x is discontinuous at x equal to 1. Okay, next case we have to check for if x is greater than 1. Okay, so greater than 1, again infinite values we have no. Okay, so we can have a common name as a c. Let c be the any real value, at the same time c is greater than 1. Now f of c value we need left hand limit of the c, right hand limit of the c is required to check the continuity. Okay, and if it is greater than 1, by default what function we have? 4x only we have. Okay, now case 5. If x is greater than 4, one second, sorry, greater than 1. So if x is greater than 1, function only 4x. Okay, so if it is greater than 1, infinite real values we have no. Let's c be any real value, at the same time c should be greater than 1. Now if f of c, so suitable function 4x, no, that means this is 4c. So basically we are going to check the continuity for this interval. Okay, we have taken the c, no, so we need f of c. So f of c just now we found that is 4c. Now left side closed values and right side closed values, and both are greater than 1 only, that means single function only we are going to deal. So we can combine both together. So limit x is approaching to c, f of x. So f of x is what? 4x. So replacing the suitable function, now applying the limit, that is 4c. Now we can see that f of c and limit x is approaching to c, f of x both are same, no. So from this what we can say? F of x is continuous if x is greater than 1. Okay, now from above all 5 cases, we can notice that at one place the function is discontinuous. So if x is less than 0, function is continuous. Exactly 0, function is continuous. Even in this 0 to 1, here also function is continuous. Yes, at x equal to 1, the function discontinuous. Okay, so we can conclude that therefore f of x is discontinuous only at x equal to 1. Okay, so for the excluding the 1, for the remaining all real values, the function is continuous. Okay, so that's all the solution. Thank you for watching, and please do subscribe. Thank you.